Hi guys, so today we are going to take a look at macromolecules. This graphic organizer can be found under week 10, 11, 5 notes. All right, so what is a macromolecule? A macromolecule is a large, complex, organic molecule made from the products of smaller molecules. And those smaller molecules are the monomers. Ooh, spelled complex wrong. All right, so ladies and gentlemen, what do we mean by this? In order to actually understand what a large, complex organic molecule, first of all, let's start with the word organic. And for that, we're going to come down here to carbon. Ladies and gentlemen, when we are talking about carbon-containing compounds, what we are talking about is basically organic chemistry. Now, some people might call this biochemistry. And that's okay too. So basically, organic chemistry or biochemistry is the chemistry that affects living things, which is why we care about it in biology. So why do we care about carbon if we're talking about biochemistry? Well, all living things here on planet Earth are carbon-based life forms, which means all of our macromolecules, which are the building blocks of living things, are all have carbon in them. So why carbon? What is up with carbon? Why is carbon so special? Well, first of all, guys, carbon only has 1, 2, 3, 4 valence electrons. And again, remember, the valence electrons is the electrons in the outermost energy shell. Well, 4 means it doesn't really want to run around and steal electrons. It doesn't really want to give its electrons away either. What that means is carbon is very, very flexible. It will make single bonds, double bonds, triple bonds. It will form rings. It will make chains. It will make sheets. It will make a lot of complex forms. This complexity that carbon is allowed to do, because it only has those 4 valence electrons and it's very small, is the reason why it is a central element in all life chemistry, in our organic chemistry. So what does high carbon end up bonding with to make molecules of life? Well, hydrogen, oxygen, nitrogen, phosphorus, and then we're going to say others. But those are the big ones, okay? Hydrogen, oxygen, nitrogen, and phosphorus. All right, so we also said that a monomer was made up of smaller molecules, and that these smaller molecules were referred to as monomers. So what the heck is a monomer? So a monomer is a small molecule that joins with other molecules to form larger organic compounds. All right, so it is, so what do we mean by this? What we mean by this is that it is the most basic building block of the macromolecules and polymers. What are some examples of these small organic molecules that are the building blocks of the macromolecules? Well, we have monosaccharides, we have amino acids, we have fatty acids, and we have nucleotides. Okay, so monomers, when they form chains, when they bind to each other, they form these long chains. Those are what these polymers are. They are large molecules made up of monomers that are linked together in a chain. So I want to remind you guys of our example. We said previously that if a monomer is like a single pearl, then a polymer is a collection of these pearls in a chain. So again, if a monomer is like a pearl, then the polymer would be like a pearl necklace, where you have all these individual units linked together in a chain. So what are some examples of polymers? Well, we have DNA, we have proteins, we have oils, starches, etc. All right, so ladies and gentlemen, so now we can go back to our original definition. A large complex organic molecule made of the product of smaller molecules or monomers. So what this tells me is that all macromolecules, all life on Earth, that it must be carbon-based, okay? And that it is built of monomers. Monomers build polymers, and polymers build macromolecules. So you can think of it in that kind of hierarchy. If I am looking at how does a monomer become a polymer, then what I'm looking at is a process, because all things have processes. The process of becoming a polymer is called polymerization. And this is just the scientific name given to the process of turning monomers into chains of polymers. All right, so we had said earlier that all living things have this thing called metabolism, where we bring in material from the outside world, and that outside material from the outside world will help us sustain our life functions and also give us energy. So we are going to bring in a lot of these macromolecules from the outside world as human beings through eating. All right, so let's say I'm going to eat this cheeseburger. Well, the bun is mostly made up of carbohydrates. That is the first of our macromolecules. The second macromolecule that I want to talk about is the cheese. And cheese are made up of lipids. Okay, so we have carbohydrate, that is our first macromolecule. We have lipids, that is our second macromolecule. And lipids are fats and oils primarily. Now, the patty itself, the meat patty here, this is primarily going to be the macromolecule protein. Okay, and finally, lettuce is going to give us our nucleic acid. And actually, a lot of things can give you nucleic acid, but for the purposes of this example, we are simply using lettuce. All right, so here are our four macromolecules. Once again, number one, carbohydrate, supplied by the bun. Number two, lipids, which are your fats, supplied by the cheese. Number three, proteins, provided by the meat patty. And lastly, nucleic acids, which are provided by the lettuce. Ladies and gentlemen, thank you for joining us, and hope this helps.